So if we add two quantities to get a derived quantity, then we should add their uncertainties in order to get the uncertainty in the derived quantity. Now what happens with subtraction? Well, subtraction is just addition where one of these numbers is negative, but we haven't paid a lot of attention to the possibility of negative numbers thus far. So back up here with the linear multiplier, what if our multiplier wasn't 10, but it was minus 10? Would we expect our uncertainty to go negative? What does a negative uncertainty even mean? Ultimately, we're talking about this delta x as just this distance, and so we're assuming that it's positive, and our value could be anywhere between x minus delta x or x plus delta x, or indeed possibly in the tails of some distribution of about that width. So we're really thinking about the uncertainty that we're quoting as a positive number. It's like the size of our uncertainty. And remember, if this graph went that way, we wouldn't expect to get a negative number therefore. So what we really should be doing is we should be putting an absolute value around whatever thing we get out of here. And that absolute value will make sure that our uncertainty comes out to positive. Now if we've got two quantities combining to give our derived quantity, then the error in either of them is going to cause an error in our final result. And so we should really be taking the modulus of both of them because they should both be increasing the size of our uncertainty in our derived quantity. So if we have addition or subtraction, we should actually be taking the absolute value of both of the terms that we get out. And so in fact, addition or subtraction, in both cases, you add the uncertainties. So in other words, supposing I go forwards a meter plus or minus a centimeter, and then I go backwards a meter plus or minus a centimeter. Now on average, I end up at exactly the same place. But there's uncertainty. There's uncertainty on my step forwards, and then there's another different uncertainty on my step backwards. And so those uncertainties are not going to cancel. So I'm going to end up back where I started, but now I'm going to have an uncertainty of 2 centimeters from my starting position. So even though I'm subtracting the values, I'm subtracting my A and my B from each other, my measured values, I still have to add the uncertainties. Okay, now what happens when we multiply values? Then we can follow exactly the same process again. And we expand out the bracket, we're going to have 4 terms. We're going to have A times B, which is going to cancel with that A times B. We're going to get terms where we have an error times the other value. And then we're going to have the term where we have the 2 errors multiplied together. And what we normally do is we normally ignore the term when we have the 2 errors multiplied together because we assume that they're both quite small, or else most of our approximations are going to get a bit loose anyway. And so when we multiply 2 small numbers, we get a tiny number. And so we're going to end up with just those 2 cross terms. And a good way to remember that is to divide both sides by y. So if we have our error in y divided by y, that's going to be what we just worked out, divided by our definition of y in the first place. And so we've got 2 terms here, and so when we have the first term, the a's are going to cancel, and the second term, the b's are going to cancel. And this quantity where you divide the uncertainty by the quantity itself is called the relative uncertainty, whereas the error just by itself is called the absolute uncertainty. And the rule is very simple. If you're multiplying things, you add the relative uncertainties. And a similar argument tells us the same thing works for division. Okay, let's do a couple of examples. So let's suppose that we have a box of apples. We've got 100 apples, and we weigh them. And we figure out that their mass together is 10.3 plus or minus 0.2 kilograms. So how much does one apple weigh? It's going to have mass. Well, there's 100 apples, we divide by 100. So we're going to get 100th of our average, and we're also going to get 100th of our uncertainty. And that's the mass of one apple. Now suppose we wanted to know how much area the box has on one side, and we measured its height and its width. And if we measured some values for the width and the height with a particular uncertainty, then it's easy enough to get the average area. We simply multiply our width by our height. But what do we do for the uncertainty? Remember, we have to add the relative uncertainty. So the relative uncertainty in this quantity is 1 centimeter divided by 120 centimeters, which is 0.8%. And the relative uncertainty in this is 2 centimeters divided by 23 centimeters, which is a lot larger, which is 9%. So remember, we have to add the relative uncertainties when we're multiplying two numbers. And so we add 9% and 0.8%, which rounded gives us 10%. And so our error here is going to be 276 square centimeters. But remember, we can't quote all these extra significant figures down here. And if we're going to have an error that big, which is going to round to 300, then there's no point quoting this number either. So the way we'd quote that properly is like that. So we've got the right number of significant figures in both our uncertainty and our final result.